Okay, welcome to another Orbiter 2010 video. This video is going to be sort of an addendum to one of my previous videos that I did back in January of this year, 2012. I did a video showing how to go from the moon back to the Earth so that you would arrive in plane with the ISS. One thing about that video that I didn't take into consideration was the idea of not only arriving so that you would be in plane with the ISS, but maybe perhaps arriving at the exact moment that the ISS would be passing your location so that you would be in plane and able to do a docking maneuver basically right away. So I thought I would address that in this video. Now, to save time, since I've already got a video on how to do this, I'm at the point where I'm still at the moon. You can see, here I'm at the moon. But I've already completed all the steps, and I've already done the ejection burn to take me back to Earth. So I'm just going to warp time ahead, and because basically the only thing that needs to be shown in this video is how to do the different mid-course corrections so that you arrive at the right place in the right time. So let's go ahead and warp time ahead. Let me kill rotation. And we need to get out, quite a ways from the moon before we worry about any kind of mid-course correction. So let's warp time ahead. And go to 10,000 for a while. Alright, let's see where we're at. Okay, we've got a little ways to go yet. What I'm looking for here is when view escape plan changes to eject plan. That'll be the time to do the first mid-course correction. And I find usually with this maneuver that I want to do 3 mid-course corrections. The first one is the most, will give us the biggest change, and then we'll do 2 minor adjustments as we get in closer to the Earth. Okay, so the escape plan changed to the eject plan, so now we can begin our first mid-course correction. To make this easier to see, I'll bring up an external MFD, make it nice and large. There we go. Come over here to view maneuver, turn maneuver mode on, and the first variable I want to work with actually is this date. This burn isn't too terribly time sensitive, but the upcoming burns will be a little bit more time sensitive, so let's just get in the habit of thinking about this now. Right now it's this date 0.9218, so let's bump this out to say 9300. That should give us enough time to, that's good enough. That should give us enough time to set this up. So let me start with a little bit of outward. Go down to maybe a fine setting. First thing I need to do is bring down my orbital altitude, and the time that it took me to go from the moon to the point that I'm at now, my difference in altitude has changed. So what I'm looking for is this dashed yellow line. When it starts to move in, that's when I know I'm getting to the point that I will need it to be. I essentially want this dashed yellow line to be at the same altitude as this blue line, which is the altitude of the ISS. A couple things I'm looking at here. This closest approach. Since my target is the ISS, this is telling me how close I'm going to be to my target. So I'm going to do an adjustment here, and I do, no matter what this says, I need to be at least low enough that I'm at the same orbital altitude as the ISS. So you can see that's coming down, that's good. We're down to 165 kilometers. So let me just do a little more refinement. and it's starting to bottom out at this point. So let me now go to change plane variable and try plus. Let me see something here. Okay, it's going to do an adjustment, go down to super. Okay, that's at its lowest point. Now let me check prograde. Go down to a much finer setting because that was really sensitive. I'm going to go back to outward. I can see that my altitude looks to me like it's still a little bit high, so I definitely need to bring this down a little bit, even if this says that it's going up. See, that says it's going up, but I still need to bring the altitude down a little bit. Now I'll go back over to prograde, do an adjustment. There we go. Now that'll let me get closer in. So we're down to 43 kilometers. Alright, let me just check the other variables. Go back to outward. Down to 41. Check change plane. Okay. Let me check outward again. Okay. Down to 38 kilometers. Down to 25 kilometers. 27. So basically what I'm doing is I'm going back and forth primarily between outward and prograde, and each time I bring outward down a little bit, it sometimes is setting my closest approach higher, but then when I go back to prograde here, I ultimately end up with a lower closest approach. Okay, let me check plane change one more time. Alright, looks like we found the best spot for that right there. And just one final check with all the other two variables at their hyper setting. Okay, that's prograde and now outward down to hyper. Okay, I'm going to go with that. This will be the first burn, and then as I get in closer to the Earth, we'll do another one. And then when I get in really, really close to the Earth, I'll do one last final burn, which will basically just be a whisper of thrust. So let's bring up view target, and you see by bumping the date out to 9300, it's giving me a countdown here, which for this particular burn I don't think it's absolutely necessary, but for the next two burns we do want to take into consideration the time.
Translation, rotation.
Let's get rotated. Okay, and I'm going to warp time ahead, because that's 400 seconds, that's quite a ways yet. Okay, back to real time. Check my green X, make it nice and lined up. And this is quite a bit of delta V, so we will bump the main engines a couple times. Burning in 2 seconds. And burning. Okay, begin throttling back a little bit. And we'll throttle down a little more. Three, 2, 1, and we'll get the rest of this with translation. Get a nice low number there, 0.003. Okay, back over to view maneuver. Off. And we've got a closest approach of 18 kilometers. We'll do another refinement here. When we get out to, say, 0.8.
Rotation.
Go ahead and warp time ahead. Now we are within the point where Earth is the strongest gravitational influence, as indicated here in the orbit HUD, and indicated down here with the gravitational indicator now showing green. Okay, there we are at 0.8. Let's go with that. Bring the external MFD back up. If TransX, if the math model of TransX was a little, I don't necessarily want to use the word better because I don't want to say that TransX is not a good MFD because it's awesome. But if it had more things taken into consideration, then we probably wouldn't need this additional mid-course correction. But the problem is, when we do that first mid-course correction, we're far enough away from Earth that the TransX isn't doing its calculations accurately enough. So as we then get in closer, like I am now, and now it shows my closest approach to the ISS is 183 kilometers. So now I can do another mid-course correction, and this will be much more accurate. But that first mid-course correction that I did when I was quite a ways out, I feel it's necessary to do it that far out, just due to the fact that we want to get our timing right. So let's go ahead and go through the variables now. And I believe, again, well, I almost forgot about the date. Right now it's date 0.4937. Let's bump that out to, let's just make it 500. Good enough. And we'll start with outward. And we'll just go minus. That's improving the closest approach. So let's just keep adding in outward until it won't go any lower. Adding in negative outward, I should say. Okay, it's bottomed out, so let's go hyper and find that lowest point right there. Let's go to change plane, see if we can get any improvement here. Nine kilometers. And that's bottomed out. So let's go to hyper and find that lowest point. It's about right there. Now let's check prograde. Oops. Go hyper. Looks like 8.5 something. 8.573. Now I'll just circle back around to outward. Do a little bit more adjusting here. And we just repeat this process until it's as low as it'll get. About right there. Okay, we're down to 5.5 kilometers. Okay, we're not really getting much benefit out of prograde at this point. Down to 4.8 kilometers. Three and a half kilometers. So it looks like back and forth between outward and plane change at the moment. 2.5. .5. Just bear with me a moment, we're almost there. 900 meters. So close. And this is more than good enough, but let's just get it in as much as we can. 850 meters, let's go with that. That's very close, and I've got to do one last refinement here in a little bit anyway. Okay, so view over to target.
Translation. Rotation.
I do wish also that TransX gave me a better indicator for which way I needed to rotate. Because sometimes when the green X is backwards, you don't know which direction to go. Okay, let's go ahead and warp time ahead now to get to the time to begin that burn. Back to real time. Line up the X. And we'll bump time forward a little bit more. And you can see I've only got 8.6 of delta V, so just 1 or 2 clicks of main engine will be good enough. Beginning the burn in 1 second. And burning.
Translation. .001. Alright, turn maneuver mode off. And you can see closest approach, 850 meters. So now I'm going to go forward all the way to the point that I'm just very, very close to periapsis, and then do any last adjustments that need to be done. And with any luck, we won't have to do any, but most likely we'll have to do some adjustment. Rotation.
Kill rotation, warp timeout. Yeah, we're about 2 kilometers off, so we'll have to do one last adjustment. Okay, it's close enough. Let's do our final adjustment. Maneuver mode on. And we'll see what prograde does for us. Wrong way, let's go this way. That doesn't look like it's doing anything, let's just reset it. Again, date
Almost forgot about it. 8773. Let's just make it even at 8850. Should be good enough. Go with that. See what outward does for us. Okay, that's coming down. And let's check plane change. Wrong way. Go to hyper. And it's got us all the way down to 500 meters. Definitely good enough. Press VW to get over to target view.
Translation. Rotation.
Get the green X lined up. Warp time ahead to that point, and you can see it just got a whisper of delta V there. Okay, back to real time.
Translation.
And translation burn in 2 seconds. Okay. Turn maneuver mode off. And now as we're getting here really close to the Earth, let me go prograde just to see exactly where we're at. There's a couple things I need to do. Need to bring up the ComNav and set this to the frequency of the ISS, which is 130. Okay, go ahead and close that out. And I can switch the HUD over to the dock view, which is what I'll be needing here when it comes time to do this. What we're actually going to be doing is, well, we'll see here in a moment. Let's just warp time ahead, get closer to the periapsis. Okay, I'm going to go retrograde. Okay, I'm 600 seconds away from periapsis. This is the ISS. This is us. And we're closing in. We're going to rendezvous right here at about that point. A couple things I'm looking for. Eventually, when I get close enough to the ISS, this dock HUD will update, and it'll tell me how far away I am from the ISS and what our difference in relative, or what our difference in velocity is. And I can also bring up the docking MFD to get even more information in that regard. Okay, there we have it. So I'm now 900 kilometers away from the ISS, and I'm closing in at a rate of 3,300 meters a second.
Rotation.
What I need to do is rotate the vessel so that I'm pointing at the reverse velocity vector of the ISS.
right here. And now what I need to know is when to burn and how much to burn. And since I'm not Rain Man, I can't do that calculation in my head. So what I'm going to do is use burn time calculator to tell me how long it will take me to use the full power of the main engines to eliminate this much velocity. So I'm going to put in dV, and then I'm going to type in this number, but you can see this number is going up, so I'm going to just estimate at, say, 3,500, because I imagine by the time it is time to do the burn, that number will have reached that point or close to it. So according to burn time calculator, to eliminate 3,500 meters per second worth of velocity using the main engines, I need to begin the burn when I am 310 kilometers away from the ISS. So I'm just going to wait until I'm at that point and then start the main engines. You may be wondering, well, what happened to the orbit circularization burn? Well, actually, that's what we're doing. Since we are rendezvousing with the ISS at the exact same time that we're arriving at Earth, we're just killing two birds with one stone, so to speak. We're going to circularize our orbit and rendezvous with the ISS simultaneously. Pretty cool trick. Getting fairly close to that point. We're at 500 and let's call it 500 kilometers from the ISS, and I need to begin the burn when I'm 310 kilometers. This number is not climbing quite as fast as I thought it would, so let me put in 3475. So to eliminate 3,475 meters a second, I need to begin the burn when I'm 305 kilometers from the ISS. So we're getting pretty close. Let's make sure we're rotated to the right direction. I want this exactly on that circle in the middle. Like that. Now, again, 305 kilometers, coming up very soon. But I estimated a little high, so we'll say 303 kilometers. And burning. So you'll see here, we're circularizing our orbit, and we're getting closer to the ISS by the second. If I switch to a different color, you can see it better. Distance to the ISS, 230 kilometers. And I can go ahead and press T, speed this up a little bit. Down to 40 kilometers. Let me get myself lined up a little better. Down to 30 kilometers from the ISS. And you can see, obviously, our orbit's becoming more circular. And we're down to 15 kilometers from the ISS. I'm going to slow down my engines a little bit. Yeah, no, let's go back to full main. 5 kilometers.
5,000, 4,000, 3,000, 2,000, 1,000, 700, 600.
And the difference in velocity is now, it's almost 0. Difference in velocity is now 0. You can see that there. Orbit is circular. Got the ISS right there.
Translation. Rotation.
So now we can just rotate over.
Translation.
Put our velocity vector right on the ISS. And there we have it.
500, 400. Rotation. Translation. 300.
Okay, so we brought the XR2 back from the moon, and we got into a stable orbit around the Earth and rendezvoused with the ISS all in one go. And obviously all we have to do to dock is just move forward 200 meters and pick one of these docking collars. So there you have it. That's the end of this video. If you enjoyed it, please leave a comment down below, and I'll see you next time.